Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be continuing what we have done in the previous video. We'll be understanding some more concept based on polynomials. But before I reveal what is the topic for the today's video, I would like you to take back to the school days, right? I just want that there is a number 15, right? And I want to divide this 15 by 6. So in school days, we used to do this way, right? Used to write 6 here. And we used to figure out what is the closest multiple of 6. What is the number which comes in a table of 6, which is very close to 15, either equal to 15 or just less than 15. Of course, 15 is not divisible by 6. That is quite obvious. So the closest number is 12. And that happens when 6 is multiplied by 2 times. So here I write 12 and I take the difference, right? This is how we used to do, right? If you are feeling nostalgic about the school days, then it's good that you have gone through this particular method of division for sure, right? Now, if I just go through this entire division, I can figure out certain things, and that is, this is the number which has been divided, right? So this number is called dividend, right? This is the number which is dividing. So we call this as divisor, right? This number which obtained is called quotient, right? And this thing, whatever is left, because further we can't divide 3 by 6 because this number is less than 6. So this number is called remainder, right? Somehow, for example, I miss this number x, this number 6, right? Say we don't know what this number is, and only this much is given to us. Can we figure out what is the value of 6? What is the value? Now let us suppose that we have been given that now let us take a scenario wherein this thing is not given to us. This thing is not given to us. We are only given divisor, quotient and remainder. Can we identify the dividend? Let me assume it to be n, right? Because n is a variable, I'm just assuming it to be n. Can we identify n if I know the divisor, quotient and remainder? The answer is yes. How? This value n, which is dividend, should be equal to 6 multiplied by the quotient plus the remainder, right? What happens is that dividend is equal to divisor multiplied by the quotient plus the remainder. This is the relationship between dividend, divisor, quotient and remainder. Now this is quite obvious in numbers. We all have gone through these things in our school days, and we also know that if I change the example, all of us can do this thing. My question is that can we do the similar kind of things in polynomials? That's the topic for today. Right? Yes, we can do the similar kind of thing, very much similar kind of things in the polynomials, that there'll be a polynomial, which will be a dividend. There'll be a divisor, which will be another polynomial. After dividing, we'll be getting a quotient, which will again be a polynomial. And in most cases, or some of the cases, we'll also be getting a remainder, which will be a polynomial, right? Here, everything is numbers. So if I just transpose everything in polynomial, every specific 4 things like dividend, quotient, divisor and remainder will also be a polynomial. But how this division is done in polynomial, that is important thing, because we can't straight away divide the 2 polynomials. We have to follow a particular steps. So we'll be following those steps. I'll be discussing those steps also. And after that, we'll also be understanding what is remainder theorem and factor theorem. If the time permits, I'll also be touching that, right? So let's start with the process of finding the method of dividing 2 polynomials. So let me take one polynomial p of x, right? I'm taking that polynomial p of x as equal to 3 times of x cube minus 8x plus of 5, right? This is one of the polynomial. I want to divide this polynomial by another polynomial, which is say x only, right? So this is the divisor, right? And this is the actual polynomial or the dividend. Now, if I divide p of x by x, what do I get? It will be 3x cubed minus 8x plus of 5 whole divided by x, right? This I can separate term wise, so it will be 3x cubed divided by x minus 8x divided by x plus of 5 divided by x. Clearly, this x will get cancelled out 2 times. This x will cancel out. So I'll be getting 3x square minus 8 plus of 5 divided by x. So 5 is not divisible by x here. That simply means that this much portion is divisible. 5 is not divisible. So this is the quotient. This becomes the quotient and 5 becomes the remainder, right? Now, if I write in this particular format, do I get this or not? Let's see. So we should get P of x when the divisor, here the divisor is what? X. The divisor is x. It is multiplied with the quotient. The quotient is how much? 3 times of x square minus 8 of x plus the remainder. What is the remainder here? 5. Let us see, do we get this or not? So here x is multiplied with this, we'll be getting 3x cubed minus of 8 of x plus of 5. Yes, we are getting it. That means this method also works for the polynomial, right? So right now I have taken a very simple divisor, which is x. If the divisor is also a bit more complicated polynomial than x itself, then also will this method work? And in that case, how do we proceed with the division? Let's see. So again, I'm taking the same divisor. I'm taking the dividend same. I'll be changing the divisor. Let me change the divisor. So let me just remove this. Here, I'll take the divisor, say d of x, which is nothing but equal to x plus 1, or say x minus 1. Let us take it x minus 1. Then how the division process is done? Let's see. What we do is that we put the p of x here, which will be 3x cubed minus 8x plus of 5. And here I'll be putting x minus 1. Now here the process, the steps are very, very important. Please listen it carefully. Here we just ignore everything. We just focus on the first term. And in fact, there is one more thing which I just missed, is that the divisors, the dividend, this thing should be written in a term wise such that the degree is in a decreasing order. Here 3 of x cubed has a highest degree, so I'm writing it here. Then x is equal to 1 is the next highest degree, then I'm writing 8 of x, and here it is 5, right? So we have to write in that particular order, and then we have to focus on the very first term. The very first term is 3x cubed. Here the first term is what? X. So we have to divide it by x, and we have to find the quotient, and that quotient is what? 3x squared. So this term will become my first part of the quotient, right? Now we know that this, when multiplied by this, I'll be getting 3x cubed, right? Then next is minus 1 multiplied by this, I'll be getting minus 3x squared. This is what we have to do. This thing would be deducted from this. Clearly, if there's a minus sign here, this will become minus 3x cubed and this will become plus 3x squared, right? So here I'm writing the, the resultant sign. So here the resultant sign will be minus, here the resultant sign will be plus. Clearly 3x cubed minus 3x cubed, they will get cancelled out. Why we are doing this thing? Because we want to cancel the very first term. This is the reason we want to find out what should be multiplied to x so that we get the first term, right? This is the logic behind it. Now, these two are two different kind of terms, right? Because the degree is different. So we'll be just writing whatever is left. So here I'll be getting 3x square. I have to ensure that they should be in a decreasing order of degree. Next thing is minus 8x plus 5. So I'll just write down whatever is left. Now this thing left over will again become my dividend. And I'll repeat the same process. Again, I want that it should be 3x squared should get eliminated, right? So what should be multiplied with x so that I should be getting 3x squared? Now it is quite clear that if I do 3x squared divided by x, I'll be getting 3x. So 3x should be multiplied by x so that I should be getting 3x squared. So the next term is plus 3 of x. Again, x into this I'll be getting 3x squared. Minus 1 multiplied by this, I'll be getting minus 3x. right? Again, this will be with minus sign, so this will become minus and this will become plus, resultant. This will get cancelled out, minus 8x plus of 3 of x. I'll be getting minus 5 of x plus of 5. I'm just retaining the leftover thing. Again, I'll be repeating the same logic. What should be multiplied with x so that I should be getting minus 5 now in this case. So I should have minus 5 here so that this become minus of 5x. X into minus 5x will become minus 5x and minus 1 multiplied by minus of 5 will be plus of 5. Now the sign will change. This minus sign will become plus sign because I have to multiply everything with minus sign. This will become minus sign. So you can see that this will get cancelled out. This will get cancelled out. Resultant will be getting 0. So in this case, the remainder is 0. In this case, the remainder is 0. What happens when something is divided by something else and the remainder is 0? Right? Let's take an example from numbers. If I divide 12 by 6, it will go 2 times straight away and I'll be getting remainder as 0. In this case, we can surely say that this is the factor of 12 because 12 comes in a multiple of 6 or in a table of 6. 12 can be written as 6 into 2. So if some number is written as product of two different numbers, then each of these numbers are called factor of this number. And this is called multiple of these factors. The same thing is applicable for polynomial also. So in the polynomial, if we divide any polynomial by another polynomial and the remainder is 0 following this particular process, then we say that this polynomial, the divisor becomes the factor. Divisor becomes the factor only in the case when the remainder is 0, right? So if the divisor is factor, can I write p of x in a similar fashion? Because if this is the dividend, this is the divisor and this is the quotient, can I write it like this? Yes, we can write. Let's see how. Let me just change the color. Here we can see that p of x is what? 3 times of x cube minus of 8x is 8x plus of 5. This should be equal to divisor, which is x minus 1 multiplied by the quotient 3x square plus of 3x plus of, sorry, minus of 5. This is minus of 5. Minus of 5. Let's see. If I open this, should I, do I get this or not? So x is multiplied by this. So it will be 3x cube plus again it is multiplied by 3x. So it will be 3x square. Again it is multiplied by this. So it will be minus of 5x. Minus 1 when multiplied, I'll be getting minus 3x square. This I'll be getting minus 3x. Again, I'll be getting plus 5. So we have to add them. The like terms will be added. So here we can see that this will get cancelled out. I'll be getting 3x cube. These two together, they are like terms. So they will be added. So again, both are in minus sign. So minus 5 minus of 3 will become minus of 8 plus 5. So you can see that this is equal to this. So this also happens in polynomial, right? So this is the factor of this. Similarly, the leftover portion, the quotient is also the factor of this. And this is called multiple of these two factors. Exactly same what it happens in with numbers, right? So I hope you have now understood that when one polynomial is divided by another polynomial, and if I get the remainder as 0, then the divisor becomes the factor and the quotient also becomes the factor, right? Now, if you observe here, there is one more thing which you need to observe. If you observe here, then here the degree of the polynomial is 3. The degree of the divisor is 1. And what is the degree of the remainder? 0. Because, not just because the remainder is 0. The degree is 0 because the 0 is a constant number. Degree is 0 because there is no variable attached to remainder. So it will always happen that the divisor has a degree which is 1 more than the degree of the remainder. The divisor has a degree which is 1 more than the degree of the remainder, right? Let me take another example that will be much helpful. So I'm taking one example. I have written it here only. If I have a divisor, say polynomial, which is say 3x cube plus of x square plus of 2x plus of 5. This is the polynomial, and the divisor is, say, x square plus 2 of x plus of 1. You have to divide it this way. Again, the process is that we need such term here so that after multiplying with x square, this should get rid of, or we should be getting 3x cube. So clearly we should be multiplying with 3 of x. So I'll be getting 3x cube here. This thing has to be again multiplied with the other terms also from the divisor. So I'll be getting 6x square, and I'll be getting plus 3 of x. The sign has to be changed. So this will be minus, this will be the minus, this will be minus, right? Clearly this will get cancelled out. This will become minus 5 of x square. This will become minus of x, and will retain 5. Again, next step is that we should get some number here so that after multiplying with x square, I should be getting this. So definitely I should have 5 here, so that minus 5 multiplied by x square, I'll be getting minus 5x square. 2x multiplied by minus 5 will be getting minus 10x. 1 multiplied by minus 5, I'll be getting minus 5. The sign need to be changed. So here it will be plus, here it will be plus, here it will be plus. So minus 5x square plus of 5x square. This will get cancelled out. Minus x plus of 10x will make it 9 of x. 5 plus of 5 will make it 10. Now further division is not possible. Why so? Because if I want to get 9 of x, what should I multiply with x square? Right? If you want to just do that thing deliberately, that what should I multiply with x square so that I should get 9x, then you'll be getting that I have to multiply it with 1 by x, right? Or x to the power 1, correct? But in the video of polynomial, we saw that a polynomial is a polynomial, any algebraic expression is called polynomial only if the powers are positive integer or non-negative integers. Here the power is a negative integer, so we can't take it because we have to ensure that the quotient is also a polynomial. So here we will stop. When we stop, that simply means that whatever is left, that becomes the remainder, right? That becomes the remainder. And you can observe the degree of the divisor is 2 and the degree of the remainder is what? 1. So the degree of remainder will always be less than the degree of the divisor, at least 1 less than the degree of the divisor, right? It can be less than that also, because if the everything get vanishes, then the remainder is a constant number. In that case also it will less, right? So I'm just correcting my statement. I said that the degree of the remainder will be 1 less than the divisor. It is not necessarily always. Yes, the degree of the remainder will always be less than the degree of the divisor. That's for sure. And whenever it occurs in the process of division, we'll just stop there. So here we can say that the dividend is 3x cubed plus x square plus 2 of x plus of 5, and that should be equal to what? Divisor, which is x square plus 2x plus 1 multiplied with what? Quotient. The quotient is 3x minus 5 plus the remainder, right? So this is the format which we'll be getting it, right? So we can say that p of x is nothing but the divisor into some quotient x, because this is also polynomial, plus some remainder which is also polynomial, right guys? Fine. So this is a simple straightforward relation we are getting. Now if I just want to figure out, or let me just change the example only, then we'll proceed. I'm taking an example wherein this number, say 4x cube plus of x square minus of x plus 5, this is divided by x plus 1. Let us do that once again. So we'll be writing 4x square. So here it would be 4x cube. X is multiplied, now 1 is multiplied, so here it would be 4x square. This will be minus, this will be minus. So this will get cancelled and I'll be getting minus 3x square minus of x minus of 5. Again, I should multiply it with minus 3x. So here it will be minus 3x square. This when multiplied it will be minus 3x, right? The sign will be changing. So here this will get cancelled out. I am getting 2x minus of 5. The degree is 1 here, degree is 1 here. So we can proceed with the division. We need plus 2. So here it will be 2 of x minus sorry, plus of 2. This will be minus, this will be minus, right? So I'll be getting, I think I have done something wrong. Yes, this will be plus, guys, right? This is also plus. So this will get cancelled. This I'll be getting 3. So 3 is the remainder, right? Now this is the way of dividing it. In the previous session, we knew that the remainder, if I want to find the remainder, the simplest way is that we should find the 0 of the divisor. 0 of the divisor is what? We have to equate it with 0 and get the corresponding value of x. So the corresponding value of x is what? -1. And if I want that what should be the remainder when this divides this, simply what we do is that we replace the value of x with -1 in this expression or in this polynomial. So let us substitute. So it will be 4 into -1 whole cube plus of -1 whole square minus of -1 plus of 5. So this becomes how much? Minus of 4. This becomes plus of 1. This becomes plus of 1. This becomes plus of 5. Clearly here we can see that this together will make it 3 and we are getting the remainder. Right? So this is the best way of getting the remainder in case of polynomial. Then why we are doing this? This we only need if we are interested in getting the quotient. Here we are not interested in quotient. That's why we only substituted the value of x to get the remainder, the end result. If we are interested in finding the quotient, then we have no other choice but to go with this method. So both the things are needed because I don't know that whether only remainder is asked or along with the remainder the quotient is asked. So both methods need to be understood. Right? Now one more thing is that in case if the remainder is 0, then we can say that this becomes the factor. For example, if I just change the divisor here, dividend here, say p of x, I'm just making a small change, is 4x cube plus of x square minus x plus of say 2. And we want to find whether x plus 1 is a factor of this now. If x plus 1 is a factor, then the remainder should be 0. When this is divided by x plus 1, the remainder should be 0. So what we should do is that we should follow this particular rule. Let us find the 0 of x plus 1. So it is equal to x is equal to -1. Now let us substitute it here. So p of -1 would be how much? It would be 4 into -1 whole cube plus 1 -1 whole square minus of -1 plus of 2. This will become -4. This remains plus 1. This will be plus of 1 plus of 2. Clearly this is equal to 0. If the remainder is 0, then we can say that x plus 1, this divisor is also the factor of this polynomial. So remainder theorem and factor theorem both are one of the same. What remainder theorem says is that if you want to find the remainder, you can just get the 0 of the divisor, substitute here and get the remainder. If you want to find the factors, then also find the remainder. If the remainder is 0, then this becomes the factor. So this method is very, very useful to find the factor of a polynomial or remainder of a polynomial. But it is only applicable, this method is only applicable if the divisor is of linear in nature. The divisor is linear polygon, is a polygon, sorry, not polygon, polynomial with degree 1. If the degree increases, then this method will not work. We have to follow this method. Right? We have to follow this method only. For example, in the previous question, if the question says that find out whether this is factor of this not. If this is a factor of the polynomial, this polynomial or not, then we have to follow this method to identify the remainder at the end. If we are getting some remainder, then definitely it's not a factor. In this case, it is not a factor, else it will be a factor, right? So this is all about remainder and factor theorem in polynomial. I'll be taking one or two more examples of the same so that both the things get clear, right? Okay, so let's take the first question. I'm taking two questions just to explain the concept. We have to find the remainder when this thing is divided by this, right? Very simple. So what we should be doing is that we should we should substitute the value of x. We should find the 0 of this divisor, right? So x minus 1 should be equated with 0. We'll be getting the value of x is equal to 1. Directly, we have to substitute the value of x to be 1 here. So obviously, this will become x to the power 1 to the power 4 plus 1 cube minus 2 into 1 square plus of 1 plus of 1. This will be 1, this will be 1, this is minus 2, this is plus 1, this is plus 1. This will get cancelled out. So we'll be getting 2. So 2 is the remainder when this expression is divided by x minus 1. Similarly, here again, we have to find the remainder when this polynomial is divided by x minus a. Again, we'll finding the 0 of the divisor, which we have to equate it by 0. So the value of x is equal to a. Let us substitute the value of x is equal to a here. So it will be what? A cube minus a into a square plus 6 times of a minus of a. Clearly, this is a cube minus a cube plus of 6a. This together will become what? 5 of a, right? This will get cancelled out. So the remainder is 5 of it, right? So this is all about remainder theorem and factor theorem for polynomial. And